Hey guys, I've already recorded this video once, but did something strange. And anyway, so I'm trying this again, and so hopefully this will work out pretty well. We are about to finish our unit on exponential functions, and specifically today we're going to look at how to apply exponential functions in like word problem type situations. So just to recap what we learned about in the earlier part of the week. So we learned that an exponential function follows the format of this: a times b to the x, and it could be y equals or f of x equals, something like that. And we learned that the a represents the initial value of the function, or the value where x equals 0, and that b represents the common ratio, or it's like that thing we multiply by to get the next number. And then x, of course, is just the variable in the equation that's going to stay there. But we're going to have numbers in for a and numbers in for b. And then x represents the input, and of course y or f of x represents your output. So we learned about that. And then today we're going to learn how to create our own exponential functions, and then how to use those exponential functions to evaluate a value in a particular problem that's given to us. So, let's look at our notes. So in our notes, we have, at the very beginning, they just kind of give you a reminder of what an exponential function looks like and what each part of it represents. So you might want to remember that the a represents initial value, or the one that has an input of 0, the output that has an input of 0. And then the common ratio, they remind you, is what b would be. And you can find that. If you don't know it, they might tell it to you, or you might be able to recognize it in a pattern. But most of the problems we do today, you won't be able to do that. So to find that, you make a ratio or a fraction with two consecutive outputs. So you'll divide the second y by the first y, and then simplify that. So if you want to make yourself a side note of that, that's the y2 divided by the y1. And then you just put those values in to this format. So you need to be comfortable with the proper format for an exponential function, and you need to know what each piece represents. The a is the initial value, the b is the rate. So let's look at an example of a problem involving stuff. So problem number 16 down here talks about the population in a city and gives some information in a table. It says the population of a small city is shown in the following table. Assume the population grows exponentially. Let t equals 0 represent the year 2000. This is going to be important to us. So the first thing they ask us to do is to write an exponential function model for this situation, and they tell us to round our decimals to 2 places. So if we're writing a function for population over a period of time, then we could write our function as p of t equals. And so we know that population is going to be the p of t, which means years has to be t. But they tell us here to let t be 0 for the year 2000. So we're going to modify this. We're not going to use the numbers 2000, 2001, and 2002 in our function. We're going to let t be 0 for the year 2000, which means 2001 would be 1 and 2002 would be 2. And that just gives me something a little bit smaller to work with. It's easier to do that way. So our function for this then, if we're going to write it, we have to know our initial value, and we have to know our common ratio. If we can pick both of those things out, then we can create our function. So initial value is usually pretty easy. That's just the value when the x is 0. So if you look at this table, 0 is here. This is that value. So my initial value is going to be 12,545. Now the common ratio is what you multiply this by to get that. Now I don't know about y'all, I'm pretty good with math in my head, but I have no idea what you could multiply 12,545 by to get 15,269. So since I don't know that, I can find that by dividing the second one, 15,269, by the first one, 12,545. And so I'm just going to grab a calculator and I'm going to do that math. So 12,545 divided by, nope, I lied, 15,269 divided by 12,545 equals, and I get 1.2171 ... craziness. So they asked me to round to 2 decimal places, so that means I'm going to round the 21. The 7 that comes behind it tells me to round that up. So I'm going to use 1.22 as my common ratio. And I'm sorry that I'm having to do this on my iPad, but my internet on my computer is still down. And so my handwriting is not as good, and I write a lot bigger. So anyway, I apologize for the not so tidy work that you're seeing here. So once I have those 2 pieces of information, so I had to have an initial value and I had to have a common ratio, I can just plug them in for the function. So the initial value goes in the A spot. So 1, 2, 5, 4, 5. In the B spot, I put the critical ratio, or the common ratio. And then I raise all of that to the x power. You will always have an exponent of a variable up here. Oh, I don't want to raise it to the x. I want to raise it to the t. And the reason is because they told us to use t in the problem. So let me shrink that eraser. My bad. Okay, so I'm going to raise that to the t. That's my exponential function. Now the next thing they ask us to do is to use that function to predict the population in 2008 to the nearest person. So that means we're going to round to a whole number. But if we're predicting the population in a particular year, we know that t is the thing that represented years. And so I'm going to have to sub something in for t to solve this. So I'm going to take my function that I wrote, p of t equals 1, 2, 5, 4, 5 times 1.22. But instead of t, I'm going to put a number. Now, if 2000 was 0, and 2001 made 1, and 2002 was 2, then 2008 will use an 8. So I'm going to replace the t with an 8. And then I'm just going to type that in my calculator. 1, 2, 5, 4, 5 times 1.22 raised to the 8th power. And so I end up with 61,567.18 craziness. Now they told me to round to the nearest whole number, the nearest person. So the 1 that comes right after the decimal here would let that 7 that comes right before it stay 7, because 1 is less than 5. So I'm just going to call this 61,567 people. That would be a prediction of what the population would be if it continued to grow exponentially until 2008. Now, C asked us to use our model to predict in what year, so we're predicting the year that the population would reach 50,000. So again, if you go back to your function, remember the T represented the year, and the P of T represented the population. So this time when they give me a population of 50,000, that means they tell me P of T. So I'm going to sub in for P of T instead of regular T. So that means it's going to look like this. 50,000 equals 1, 2, 5, 4, 5 times 1.22 to the T power. And I'm going to solve that for T. Now, we learned how to solve exponential functions Tuesday in class because we used Desmos to do it. So I'm going to get Desmos, and I can just drag this over here. Oh, well, that's interesting. Let's see if I can figure out how to bring that to the front. Okay. So I can pull up Desmos, and you can open this in another tab, but you should be able to access it. Go away, thing. Okay. And we are going to type in that function. So now if you remember when we did this in class, we typed the function in the top. So I'm going to type 12545. And then times 1.22. Oops. 0.22. I'm going to raise that to the x power. It doesn't really matter what exponent you use there, or what letter you use. And then for the part that it equals, remember you have to type y equals that number. So this one's going to equal 50,000. So I type y equals 50,000. Like that. So the original function goes in the top. What the function equals goes in the second line as y equals that number. And then I'm going to zoom way out, because I got to find 50,000. And so you'll see two lines. When you create this, you'll see two lines. You're looking for the intersection of those two lines. And the intersection for me is 6.953, comma, 50,000. So this 6.953 is our solution to this one. So I'm going to go back to my actual problem. And so this t equals 6.953. Now remember, t represents the time after 2000. And so if they want us to figure out to the nearest year what year it would reach 50,000, then we would say it's about 7 years after 2000, which would be about 2007. Okay, so let's look at another one. This one asks you to try the same thing. So if you feel like you want to try it yourself, you can pause this video. If you think you need to watch me work another one with you, then you just keep watching. But you can do whichever way you feel comfortable with. So this one says the table shows the value V of n of a car after n years after purchase. Assume the value decreases exponentially. So we are, so we look at this table and we see that they show us the years after purchase and the value of the car, and it is decreasing. A asks us to write an exponential function model for this, and they tell us to round to 2 decimal places, so that's going to be important to us. Now what we want to pick up on with this one is that we're using n for the input and v of n for the output, so we want to make sure we're using the correct variables and the correct exponents and that kind of thing. So when we write our exponential function for this, we're going to have v of n equals, and then I'm going to find my initial value, and I'm going to find my common ratio, and I'm going to put those two things into the exponential function. So remember, your initial value is always the value where your input is 0. So in this table, my input is 0 right here. So that means my initial value is 24,800. Remember, that goes in the position of A. So 24,800. Now, in the B position, we have to have our common ratio. Now, same situation as the last one. Even as good as I am at doing math in my head most of the time, I don't have the slightest idea what you would multiply 24,800 by to make it become 21,328. It's not in my head. So I'm going to have to do some math to figure that out. So if you remember, to figure out your common ratio, you divide the second y by the first y. So 21,328 divided by 24,800. That's going to tell me my common ratio. So 21,328 divided by 24,800. My calculator tells me that is 0.86. Nice and neat. 86. So in the B position, I'm going to put 0.86. And always raising it to an exponent of whatever our input variable is. So for this one, they used n. We're going to put an n. That is the exponential function model for this situation. Okay, so B says if you finance the car for 5 years, what will the value of the car be when it's paid for? So we're looking for value. If you look back up here, remember V of n represents value. N represents the years after your purchase. So if I was going to use this and figure out the value, I would be solving for V of n when I know the n is 5. So I'm just going to plug that in. 24,800 times 0.86 to the 5th power. And I'm going to type that in the calculator. 24,800 times 0.86 raised to the 5th power. And I get $11,666.59. Look, if you don't have a calculator at home that does like exponents and stuff, Desmos will do it. So you can use Desmos to type something like that in, and it'll just give you the answer right underneath what you type. It doesn't even matter what it graphs because it'll tell you the answer right underneath it. So if you need to use that, you absolutely can. All right, let's take a look at number 18. 18 says, rabbit populations are known to grow very quickly. Suppose in 2000 you bought a breeding pair of rabbits. By 2001, you were the proud owner of 32 rabbits. Assume your population continues to grow and grows exponentially. So they first want us to write an exponential function model for the population of rabbits, P of t years after 2000. So remember, this is going to be our output. T is years after 2000. That's going to be our input. So we, to be able to write an exponential function model, need to know some information that's given to us in the problem. So let's see what we know about t and P of t. What we know is that in 2000, which would be a t of 0, because that's 0 years after 2000, you bought a breeding pair of rabbits. Pair means you bought 2 rabbits. By 2001, which would be 1 year after 2000, so that means a t of 1, you then owned 32 rabbits. Not because you bought more, but because your rabbits were breeding. That's what it says. Assume your population continues to grow and grows exponentially. So if this is the information for my function, I can use the initial value and find a common ratio for this and use that to create a function model. So my function model is going to be P of t equals, and then I'll look at this to see. So initial value, remember, is when the x is 0. So the initial value, the starting amount for this was 2. I was going to erase that, but that didn't exactly work, did it? Starting amount was 2. And then the growth ratio, or the common ratio, is if you don't know that 2 times 16 is 32, then you can divide 32 by 2 and get 16, but it's 16 either way. And then we, of course, raise that to the t power because t is our input. That's our exponential function model. So if they ask us to write that, we've written that by putting our initial value in for the A spot and our growth ratio in for the B spot, and then, of course, our input variable for t. Now, I'm going to use that to figure out the population of rabbits in 2003. Well, if t represents years, I know 2003 is going to have something to do with the t. But remember, it's years after 2000. So 2003 is 3 years after 2000. So I'm going to plug a 3 in for t. So I'm going to solve this as P of t equals 2 times 16 to the 3rd. And I'm just going to calculate that. 2 times 16 to the 3rd power. And I find out that by 2003, if your rabbits continued the same breeding pattern, you would have 8,192 rabbits, which would be insane. And then C asks us to figure out what year it would take for the rabbit population to exceed 100,000 rabbits. So if they tell us the population needs to get bigger than 100,000, then that means P of t would have to equal 100,000 because that's population. And we would be solving for t to figure out what year it would be. So that's going to be one that we need Desmos for. So again, you pull up Desmos and then we're going to type that in. We type the original function in the first space, 2 times 16 raised to the t or the x or whatever. And then in the second one we put y equals, and we're trying to hit 100,000. Like that. And I'm going to zoom way out because I got to get to 100,000, which is far, far away. There it is. Now I can zoom back in a little if I want. And I'm going to find the point of intersection for these lines. So for these, I get 3.902, comma 100,000. Which means my solution to this, is 3.902. So t equals 3.902. Now they asked me to round to the nearest whole year, so that's about 4 years later. So if it was 2000, 4 years later would be 2004. Okay? If you feel like you're ready to try this one, it's very similar to the last one. Try it and see if you get the right answer. If you don't feel like you're ready and you want to continue watching the video, then you can continue to watch the video here and work it with me. So if you think you're ready, pause the video. If you're not, then continue working it with me, and hopefully you'll feel a little more comfortable with it after that. Okay, so in problem number 19, it tells us that in 2010, the population of Gilbert, Arizona was about 208,000. By 2011, the population had grown to about 215,000. And they ask us to assume that the population grows exponentially. So they want us to write an exponential function model that represents the population of Gilbert, P of t years after 2010. And then they want us to round it to 3 decimal places as needed. So that's going to be important to know how to round. So again, when you go to write this exponential function, you should start out with your P of t equals, and then we're going to figure out our initial value. So the information that we know is that in 2010, the population was 208,000. And we know that in 2011, it was 215,000. And we know that t is representing years after 2010, which means if it is 2010, your t is going to be 0. If it's 2011, your t would be 1. So when I go to write this function, if when my t is 0, my population is 208,000, well, that's going to go in the spot for A, 208,000. If I know that, and I know 2 consecutive populations, so I know in one year it was 208,000, and the next year it was 215,000, I can divide 215,000 by 208,000 and get a growth ratio of about 1.03. So that means here I'm going to put 1.03 raised to the t.